Refrigeration. Refrigeration is a process of removing heat from a substance and lowers the temperature of the substance below its surrounding atmospheric temperature and maintaining its temperature at the required atmospheric level. The heat removed from the said substance is passed onto another space or substance. In short, refrigeration is necessary to prevent the foodstuffs on board from getting spoiled. The basic components of any refrigeration system working on vapor compression cycle are the compressor. Compressor is used to compress the refrigerant, producing the vaporized refrigerant of high in temperature and pressure. The raising of the refrigerant pressure will cause its saturation temperature to rise so that it is higher than that of the cooling substance in condenser. The compressor also promotes circulation of the refrigerant by pumping it around the system. On the suction stroke, where a piston is moving downward, the clearance space between the piston and the cylinder head will expand. The drop of the pressure will open the plate-type suction valve and forces the refrigerant to enter the chamber until such time as the suction valve recedes. The compression stroke will take place when the piston moving upward. During the stroke, the pressure rises to slightly above the discharge pressure and will cause the plate-type discharge valve to open. The refrigerant passes through at approximately constant pressure and flows to the condenser. At the end of the stroke, the differential pressure across the valve aided by the valve spring will close the discharge valve and another suction stroke begins. Condenser. Condenser tubes provide heat transfer surfaces in which heat from the hot refrigerant on the outside of the tubes passes through the walls of the tubes to the cooling water inside. The refrigerant vapor is cooled first to the saturation point, then to the liquid state. The condensation process will lower the temperature of the refrigerant but keeping the high pressure of liquefied refrigerant. The flows of the refrigerant will now depend on the thermostatic expansion valve. Thermostatic expansion valve. Thermostatic expansion valve or TEV works based on the expansion of the mercury inside the sensing bulb fixed in close contact with the suction refrigerant line at the outlet from the evaporator and is responsive to change in refrigerant vapor temperature at this point. When the temperature in the refrigerator rises, the mercury inside the sensing bulb will expand. The expansion of this fluid will push the diaphragm downward together with the push pin when overcoming the spring pressure set by the manufacturer. This will lead to the opening of the valve and allows the refrigerant to flow through. After some time, when the temperature inside the refrigerator falls to the desired value, the mercury will contract. The pressure drop above the diaphragm causes the spring to lift up the push pin and close the valve. The refrigerant will stop flowing and at some point after the valve closes, the compressor will cut off. Evaporator. Evaporator is used to exchange the heat between the refrigerant and the air inside the refrigerator. Since the temperature of the refrigerant is lower than the air in space, the refrigerant will receive the latent heat. The latent heat received will make the refrigerant to boil and evaporates, while the air inside the refrigerator will become cooler. Evaporated refrigerant will leave the evaporator to the suction line of the compressor, and the circulation of the vaporized refrigerant will continue until the desired temperature obtained, which is detected by the sensing bulb fixed at the outlet of the evaporator.